Good afternoon, everyone. In this lecture series, we are going to discuss about the source transformation. In the previous lecture, we have discussed about the circuit elements. In circuit elements, we have seen what do you mean by active, what do you mean by passive, what do you mean by lumped elements. These are all the things we have seen in the circuit elements. The next topic we are going to see about the source transformation. So what do you mean by source transformation and what is the need for this source transformation? So the function of the source transformation is it is used to simplify the analysis, circuit analysis, and it facilitates nodal and mesh analysis. It is useful in network theorems. So here we are going to see the two conversions. What are the two conversions we are going to see here is one is voltage to current source conversion, another one will be the current to voltage conversions. So these are the conversions we are going to see in this source transformations. So what do you mean by source transformation? Means we are converting a voltage source into an equivalent current source or vice versa. Without changing the external behavior of the circuit. So according to this, here what we are converting means the first diagram represents the voltage source and the resistor has been connected. So here we have to convert this voltage source in the current source. So according to this current source, the resistor that has been connected in the parallel. So we should not change any external behavior of the circuit. Just we have to transform the source. We have to convert that. Voltage here the voltage source has been converted into current source. Suppose if a practical voltage source consists of V and the series resistance R, the voltage is connected across with the resistance R. Now it has been converted into the equivalent current source. So the voltage source here we are having the same resistance, that is R, is connected in parallel with the connect source. So this is the diagram representation. The voltage source has been converted into the equivalent current source. This is the diagram of conversion of voltage source into current source. The next one, we are going to convert the current source in the voltage source. A practical current source consists of the current source I and the parallel resistance R. The same resistance R is connected with the voltage source. Now in this diagram we are going to see how the transformation of current has been changed into the voltage. Here we are having I that has been connected with the shunt resistance R. So this is termed to be as the current source. Now we are going to convert this current source into the voltage source. So here the voltage is equal to IR. We know that V is equal to IR. Here the shunt resistance should be equal to the series resistance. Here now the transformation has been converted into the current source into the voltage source. We are going to see what are all the rules of the source transformations. Here it is applicable only for the practical sources, and there will be an external terminals must behave identically. The power will be delivered to the load remains the same, widely used in nodal and mesh analysis. There is a comparison of the voltage source and the current source. Voltage is series with the R and the current is parallel with the R. The convert using I is equal to V by R, convert using V is equal to IR. The voltage source, it is used for the mesh analysis and the current source is used for the nodal analysis. The advantages is simplifies complex circuit, reduces number of equations, helps choose easier analysis method, and it will be useful in network theorems. So this is the example. Just we are converting the voltage into current, current into voltage. So this is the mind map. There will be a source transformation technique. There is an equivalent circuit and how it has been compared when suppose we are considering the voltage source means V is series with resistance. Current source means I is parallel with the R. We are having some of the rules is it is applicable only for the practical sources. The external terminals are identical. The advantages, it simplifies the complex circuit and it reduces the number of equations, and it is very useful in the nodal and mesh analysis. Thank you.